So far for this unit, we've been looking at trigonometry like SOHCAHTOA, right triangle trigonometry. We use it when we know we have a right triangle. Well, for this video, we're going to learn about the law of sines and the law of cosines that we can use when it's not a right triangle. Okay, so our new vocabulary, new formulas that you're going to have to memorize are the law of sines and law of cosines. So to start with, the law of sines. Okay, it just says that if we have a triangle, right, where we have our angles capital A, capital B, capital C, and sides lowercase a, b, and c, sine of A over A equals sine of B over B and sine of C over C. Okay, so it's sine of angle A over side A is the same as sine of angle B over side B, right? We don't need all three of those, but they are all the same. The ratio is the same, so we can use that to find one piece of information. So for example, now for all these examples, I've already worked them out. So if you need to pause and take a second to plug it into your calculator, please do. Okay, so for this one, I want to find P. Well, I'm given side PQ, which is opposite 29, and side QR, which is opposite 17. Or at least that's the one I'm trying to find. Okay, I don't need all three of those ratios to be able to solve. I only need two. Okay, so I have this angle here. So if I say sine 29 over the side it's across from, which is this 8. Okay, that ratio is the same ratio as sine 17 across from its opposite side, P. This is the equation that now I can solve for P. I have a fraction equals a fraction, so this is a proportion. To solve a proportion, you cross multiply. So then I get P times sine of 29 equals 8 times sine of 17. Don't plug it into your calculator yet. You want to wait until the very last step so that you don't round too early, right? Sine 29 is a number value, so to get P by itself, I'm just going to divide by sine 29. This is what you're going to plug in. Now you have to be careful in your calculator, right? Now we have to make sure we're closing our parentheses where we need to. So in your calculator, you're going to type in 8 sine 17, right? Now that's going to open a parentheses, so now we have to close that parentheses. We're going to divide by sine of 29. That last parentheses doesn't really matter in this case, but this one around the 17, you have to make sure you close it. If not, your calculator is going to think you're doing sine of 17 divided by sine 29. Right, as it's all one big number. But we want to do 8 sine 17, and then take that and divide it by sine 29. So when you plug all of that in, you should get 4.82 for P, or 4.8 if we round to the nearest 10. Okay, so in this case, I was given two angles, and then the sides opposite them. Right? For this one, example 2, we want to find x. Right, I want to find x. So x is a degree this time. Right, so I'm looking for a degree. I have 11 opposite the x and 10 opposite the 50. I'm going to write a proportion just like before. So I'm going to say sine of 50 over 10, 10 is the side opposite 50, equals sine of x over 11. I have a proportion, so I cross multiply. So 11 sine 50 equals 10 sine x, right? I want to get this x by itself, so first I'm going to get rid of 10. I've got to slowly work my way in, right? So I get 11 sine 50 over 10 equals sine x, right? To cancel out the sine, I do an inverse sine of both sides. Inverse sine. Right, and now I'm going to plug it all into my calculator. Again, when you plug it in, watch your parentheses. Right, so I'm going to say the inverse sine is going to open a parentheses. So I'll do 11 sine 50. It opens another parentheses. Oops, sorry, the parentheses comes before the 50. Okay, close that parentheses, then do your divided by 10. Okay, again, the last one doesn't matter because it's the end of our equation, but this parentheses around the 50 is very important. When you plug all of that in, you should get 57.42. So we'll say 57 degrees to the nearest degree. Alright, so go ahead and try this one. So pause here and try it, and then come back and see if you got it right. Alright, so I want to find x. So x is a degree again. 10 is across from x, it's opposite, and 12 is opposite 55. So I'm going to start by saying sine of 55 over 12 equals sine of x over 10. Cross multiply. 10 sine 55 equals 12 sine x. Divide by 12. Take an inverse sine of both sides. So I end up typing in inverse sine of 10 sine 55, close that parentheses, divided by 12. Type all that in, and you should get 43.04, which is B, 43. Oops. Okay, law of sines we're going to use based on, it all depends on what information you're given. So if you're given enough information, you use law of sines. If you're given angles and the sides opposite those angles, we'll use law of sines. For law of cosines, we won't have the same information, so this is why we have law of cosines. Okay, so law of cosines is kind of long, but it's really not that bad, right? If we have triangle ABC with side lengths lowercase abc and angle measures capital ABC, okay, we have three different equations that we can memorize, or formulas. Okay, a squared equals b squared plus c squared minus 2bc cosine a. Right? Everything's in that similar pattern. Okay, if you notice, the side we start with is the angle we use in our cosine. Okay, so whatever side you start with is the angle we use in our cosine. Okay, the other two sides, we square them and add them, and then we put them right here, the minus 2bc. Down here we started with b, so our angle was b. We did a squared c squared and put ac next to 2. And then the last one we have is c squared. Our angle is c, and then we have a and b, ab. Alright, so you really only have to memorize one formula and just know the relationship of what goes with. Okay, so whatever side you start with is where your angle is, or which angle you use. Okay, so we want to find x and round to the nearest 10. X is this side opposite the 45. Okay, I'm given 11 and I'm given 25 as other side. So here I can't use law of sines because I'm not given another angle. I don't know what these two angles are. Alright, so I'm going to use law of cosines. Now I'm looking for x and I'm given the angle x, so I'm going to make x the side I start with and 45 what I put in my cosine. So I'm going to start with x squared equals, then I square and add the other two sides, so 11 squared plus 25 squared, right? Then I do minus 2 times the other sides. Oops. Cosine, and we'll do 45. Hope you can see that. Cosine 45. Right, so then I have x squared equals, all of this I can type into my calculator just the way it's written. So you'll just type in 11 squared plus 25 squared minus 2 times 11 times 25 times cosine 45. And when you type all of that in, it simplifies to 357.09. Now I rounded on here to be able to put it on the screen, but make sure you're trying to keep from rounding until the very end. So when you go to take the square root of both sides, take the square root of your previous answer on your calculator. Right, just so we can get as exact as we possibly can. And when you take the square roots of both sides, you have 18.9. Right, so this side x is 18.9. Right, all you have to do is memorize. It seems like a lot, but you just have to memorize your law of cosines. Memorize one of those formulas, and then the pattern stays the same when you plug in A, B, and C. Right, now I want to find R, given that S is 15, T is 32, and the measure of angle R, I don't know what this is, should be the measure of angle R equals 40, and we want to round to the nearest 10. So it's already got this nice picture drawn for us. So here's my R, and it's opposite this angle 40. So I want to start with r squared and make sure I plug in 40 to cosine. So my equation would be r squared equals the other two sides squared, so 15 squared plus 32 squared minus 2 times the other two sides times the cosine of my angle 40. Plug all of the right side into the calculator, and that simplifies down to 513.6. Right? Take the square root of both sides, and that simplifies to 22.7, or answer choice C. Right? For this example, it's asking us to find the measure of angle P. Right? I don't know where that D comes from, but we want to find the measure of angle P. So now instead of finding a side, I'm finding an angle. So that means this angle P up here, I'm going to call it theta. That's what I'm going to plug into cosine. So I'm going to plug in all my sides, and then I'm going to have cosine theta at the very end. Right? So the side that I have to start with has to be opposite the angle that I plug in. Well, if P is what I'm plugging in, I'm going to start with 2.9. So my equation is going to start with 2.9 squared equals the other side squared, so 1.3 squared plus 3.1 squared minus 2 times those sides times the cosine of that angle, theta. Right? So I just plugged in everything to that same formula, but now I'm solving for theta, not for a side. So I can't plug all of this in at one time. So if I slowly start to simplify, right, I get 2.9 squared is 8.41. Right, 1.3 squared plus 3.1 squared is 11.3. Right, 2 times 1.3 times 3.1 gives me 8.06, and then cosine theta. Okay, I want to slowly get theta by itself, so I'm going to subtract 11.3 over, get negative 2.89 equals negative 8.06 cosine theta. Okay, I'm going to divide by negative 8.06. Right, once I do that, I get a number that's rounded, right? So I'm going to say 0.3586 equals cosine theta. Again, you don't even have to plug this in, right? We could leave it as 2.89 over 8.06, right? But if I plug it in, to get rid of this cosine, I've got to use inverse trig, right? So I'm going to take inverse cosine of both sides, right? So when I take an inverse cosine of both sides, I get 68.99, which rounds to 69 degrees. Answer choice D. Alright, so all you're doing is you're looking at the information you're given. You're deciding if you should use law of sines, law of cosines based on what you have. And then law of cosines, it's just a matter of which side you're starting with. Whether you do A, B, or C squared first determines which angle you put in your cosine. And that is how you use law of sines and law of cosines.